All right. So moving on to chapter 3, right? In chapter 2, we reviewed all that we knew about algebraic functions. Maybe not all that we knew, but a good chunk of what we knew. And we may have also introduced some concepts that you weren't familiar with prior to this class. In chapter 3, we're going to do the same thing for transcendental functions. And I want to, first of all, give you some idea about what we mean by the word transcendental. So in the previous chapter, in chapter 2, we talked about algebraic functions. Algebraic functions are functions that can express what happens to x in terms of a finite sequence of addition, subtraction, multiplication, division, and exponents, including rational exponents, so that, radicals are also algebraic in nature. Polynomials, rational functions, radical functions, and any combination of those things, like this crazy function here, these would all be considered algebraic functions. In this chapter, we're going to discuss transcendental functions. They're called transcendental because they transcend algebra in the sense that they cannot express what happens to x in terms of a finite sequence of addition, subtraction, multiplication, division, and exponents. In particular, the transcendental functions we're going to discuss in this class are exponential functions like this, logarithmic functions like this one, and then trigonometric functions like this. There are other kinds of transcendental functions, like hyperbolic trig functions and things like that. And you'll see some of those in calculus as well, but we're just going to review the transcendental functions that you've seen up until this point. These transcendental functions, they can't be described, like we can't describe x, what happens to x in terms of a finite sequence of algebraic operations, but we can, with these types of transcendental functions, this isn't necessarily true for all transcendental functions, but for the transcendental functions we're going to see in this section, we can describe what happens to x in terms of an infinite sequence of algebraic operations. And in fact, that's kind of a really cool thing that ties these kinds of functions together that we're going to explore a little bit in this chapter. You'll explore it in much greater detail in calculus. But in fact, we can describe all of these functions in terms of an infinite polynomial, right? So for example, e to the x can be described, we can describe what happens to x in terms of an infinite sequence of algebraic operations. So e to the x is the same thing as this infinitely long polynomial. And we will talk about this later on in the chapter. Graphing is going to be important in this chapter, just like it was in chapter 2. So you should memorize the shapes of the following graphs. So this is the basic shape for an exponential function. Okay, how quickly it rises will depend on what the base is. So here we just have the natural exponential function e to the x. It'll rise more steeply if you have a number bigger than e, right? E is about 2.7. So if you had like 4 to the x power, it's going to rise more steeply. If you had something like 2 to the x power, it's going to rise a little bit less steeply, right? But they're all going to have this shape, right? All exponential functions have this shape. And in the same way, all logarithmic functions have this shape. This one right here is the natural log. This is a log base e. But a logarithm of any base is going to have this shape, right? So you should memorize those two shapes. And then you have the shapes of then you have the 6 trig functions, right? So you should memorize the shapes of these 6 graphs as well. The last page of this introduction is something that we'll come back to at the end of the chapter, so that you'll see why it's so important for us to know so much algebra and know how to manipulate transcendental functions so much, because it's going to be necessary for you to do things like calculate derivatives in calculus. So, okay, so that's all I have to say about this introduction to chapter 3. But in a nutshell, these are the 3 kinds of functions we're going to be looking at. We're going to spend most of our time talking about the trig functions, but we will spend the first 3 sections talking about exponential and logarithmic functions. So I will see you in 3.1.